Today we're going to look just really briefly at some of the reactions of alkenes. I'm going to do one very, very short demo of it because the reactions are very similar to alkanes. So we've seen some of those previously. Combustion is pretty much the same as alkanes. Like alkanes, you generally get incomplete combustion. But it's even more incomplete because so much energy is required to break the bonds and so on. So you end up with quite a lot of soot. Also, there's not enough oxygen in air to burn most alkenes efficiently. Addition is one of our key reactions that we do with alkenes, particularly with bromine water. Now, you might remember that we had a bromine water plus alkane reaction, and even after 10 minutes we saw nothing, no reaction at all. I told you that eventually it would react, giving off HBr gas, which we could detect with blue litmus turning red because it's an acid. But really, you just have to take my word for it. Basically, in the lab, you're not going to see that do anything. But in the lab, for alkenes, you might. So I've got that one ready for us to have a look at. So what I've got here is some cyclohexene, colourless liquid. If I let you smell it, it smells really similar to cyclohexane, so it's hard to tell the two apart. If I add bromine water to this, you see it makes two layers because just like the alkane, it's non-polar, whereas the bromine water is polar. If I shake it up, the bromine itself will come into the top layer, but unlike the cyclohexane, the colour is disappearing. And it's going a bit of a milky colour, a bit of a cloudy colour at the bottom. That's because we're making a halo alkane. In this case, we're making 1,2-dibromocyclohexane. So you notice the ene, double bond, has become an ane, a single bond, as the bromine has been added to the molecule. Hence, it being called an addition reaction. This is one of the most common tests for an alkene. The other common one that I'm not going to go over today in any detail on the board is the addition of potassium permanganate, which will add a hydroxide to both of those instead of bromine, going from purple to colourless. So that's another one that we sometimes use as a test. In a future lesson, we're going to be looking at tests to tell alkanes from alkenes, and that will be one of the ones we cover in that day. Okay, so I'm not going to cover it today because you don't need to do a balanced equation for it, whereas you do need to do a balanced equation for the addition of bromine. And know that the observation was from a yellowy orangey colour to colourless, and it's got this cloudy layer due to the slightly insoluble 1,2-dibromocyclohexane. So if this was not cyclohexene but was hexene, this would be 1,2-dibromohexane. If it was propene, which you guys have just made little models of, it would be 1,2-dibromopropane. So notice that we're going to the ANE ending. We'll learn more about the halo alkanes in a future lesson, but that's just one to be aware of now. We can also make these halo alkanes using concentrated HBr, or the gas of it, HCl, any of these what we call hydrogen halides, where the X is anything from group 17. So HI, HBr, HCl, HF if you're brave enough. And you notice that it can only add one bromine to it. So rather than being dibromo, it's just bromo. Okay, so it breaks this and adds hydrogen to one of them and bromine to the other. All right. And the last one, which is one that people often get confused about, is dilute H2SO4. H2SO4 is dissolved in water. It's actually the water that's being added to it. So you'll see HOH there, so an alcohol is being made. The reason this is important, and the reason that I made you make these propene molecules, is what we're about to do now, a thing called Markovnikov's rule. And no, you do not need to remember the name of it. Okay. If I have propene and I was to add H2O to it, there are two ways that it could add. So I'm going to break this double bond, and the following two can be made. And I invite you to make these with those molecules you've got in front of you. It is possible that I'm going to go over this in colours because I'm going to show you what I'm doing. that the H could go there, or it could go there. There's two places for the hydrogen to go. And at the same time, that would suggest that the OH can go there or there as well. So here are the two possible things we could make. So I could have my hydrogen over here, or I could have it over here. And if that's the case, then my OH would be here, my OH would be here. These are both called propanol. The ANOL ending is saying that it's an alcohol, so you've got the OH group. Again, we'll learn more about alcohols later. The difference is that on the one at the top here, it's on the number 1 carbon, whereas here it's on the number 2 carbon. So this one is called 1-propanol, while this one here is called 2-propanol. Well, how do I know which one is made? The answer is that both are made. However, one of them is what we call a major product. There's more of it. When I do this reaction, a large percentage is actually 2-propanol and only a small percentage is 1-propanol. And this is where a thing called Markovnikov's rule comes in. I look at the original alkene, and I have to assign one of these 2 carbons as being hydrogen rich. The rule is the rich get richer. That's the way to remember it. Okay, the carbon that is hydrogen rich out of these 2, so the one that has more hydrogens, will get richer in hydrogen. So if I look at these 2 carbons, the one on the left, number 1, is richer. It's got 2 hydrogens on it. So it's the richer carbon. That's the phrase we use. The carbon on the right, with only 1 attached to it, is the poorer carbon. I ignore this carbon because it's not part of the double bond. It's not part of the equation. Only the 2 that are in the double bond are to be considered. This is the rich carbon, this is the poor carbon. So the rich carbon gets the hydrogen, it gets richer. The poor carbon therefore gets the other part of what hydrogen is attached to, so the OH. So this is what we call a major product, and this is what we call a minor product. Working out which is which will be testing you at the merit level in NCEA.